Hello everyone and happy Pi Day. Today is March 14th or 314, which are the first digits of pi, 3.14. But how do you know that pi is equal to 3.14159 and so on? Well, today I'm going to show you 5 easy ways that you can calculate pi right at home without any sort of fancy equipment. Alright, so the first and easiest way to calculate pi is to use the definition that you were probably taught in school, which is that pi is the ratio of the circumference of a circle to its diameter. So what we're going to do is we're going to draw out a circle, measure its diameter, measure its circumference, and then calculate pi. Alright, so for the circumference method, the first thing we're going to do is draw out a circle. And I'm going to draw this out on graph paper just because that's going to make this a little bit easier for me. So you can see there I've drawn the circle with the compass and then I've darkened it just to make it a little bit more visible. And if we count the number of boxes on the diameter, we can see that our circle has 20 boxes. So its diameter, we'll say, is 20. Now, let's calculate the circumference. So I'm going to use this string. I'm going to wrap it around the circumference of the circle and then cut it off so that the string is exactly the same length as the circumference of the circle. So as you can see there, I've laid out the string around the circumference of the circle, and now I'm going to cut it and measure it. Now, as you can see, I've actually run out of room on the graph paper, so I'm going to cut the string and measure the two parts of it separately. So as you can see, the first piece has a length of 35, and the second piece has a length of about 28. So I'm going to say that the circumference is 35 plus 28, which is about 63. So there we have it. That is the diameter of, that is the circumference of our circle, 63 units. So I've worked out the maths here, and I've moved the string to make this a little bit easier. So the length of the first string was 35, the length of the second string was 28, and that adds up to 63 boxes as our circumference. And as we know, pi is the ratio between the circumference and the diameter. Our diameter was 20, and so pi equals 63 over 20, which is 3.15. I don't know about you, but I think that's pretty darn good. The second way to calculate pi is to use the area formula of a circle. So the area of a circle is pi r squared, where r is the radius of the circle. So we can do something similar to last time, where we'll draw out a circle and we'll calculate its area to find pi. Alright, so for the area method for calculating pi, we're actually going to use the same circle that we used before for the circumference method. And the reason is that we already have the circle drawn out, it's on graph paper, which makes it pretty easy to count out the area. And the way we're going to count the area of this circle is by counting the number of grid boxes inside the circle. And so there's going to be a little bit of error on the edges because there's sort of parts of grid boxes that are inside the circle and part of it is outside. But hopefully, if we do things right, we can come up with a good approximation for the area of this circle. So you can see I'm halfway through with counting out the boxes, and what I'm doing is for each row, I'm writing the number of boxes inside the circle. So at the end, as soon as I finish the second half, we'll add up all of these numbers to get the area of the circle. And there we go. I finished counting out the number of boxes inside the circle, and I have all these numbers. And something you'll notice is that because the circle is symmetrical, we actually have the same numbers on the top as we do on the bottom. So if you want to at home, you can just count the number of boxes in the top half of the circle and multiply that by 2, and you should get the same number. But now we're going to add up all of these numbers to get the area of the circle. So I've counted out all the boxes, I've added up all the numbers, and here's what I've got. So after adding up all the numbers, I've got that the area of our circle is 312 boxes. And we know from the formula for the area of a circle that area is equal to pi times the radius squared. And so if we rearrange that, we get that pi is equal to the area divided by the radius squared. Now, if you remember, the radius of our circle was 10 boxes, and so we can calculate pi as pi equals 312 divided by 10 squared, or 312 divided by 100, which equals 3.12, which is pretty close to pi. Now, the third way to calculate pi is similar to the second way, in that it uses the area formula. So imagine we have a square dartboard, and inside of it we have a circular target. Now, we'll say that we're throwing darts randomly at this board, and every time we hit a dart inside the circle, that counts as a win. Doesn't matter where inside the circle, as long as it is inside the circle. Then, if we randomly throw darts at this square board, the fraction of darts that are winning, so the fraction of darts that land in the circle, will equal the ratio of the area of the circle to the area of the square. And with a little bit of math, we can calculate the value of pi with random dart throws. Now, as it turns out, I'm not that good at throwing darts. So instead what I've done is I've written up a quick computer program in Python to simulate throwing a bunch of darts at a square dartboard, just like I talked about. So I've written a Python program to simulate throwing a bunch of darts at a dartboard. So you can see here on the left is the square dartboard with the circular target in it. And on this diagram, each of the green dots, the tiny little green dots, represents a dart that landed inside the circle. And each of the red dots represents a dart that landed outside the circle. Now, the reason there's so many dots is that I actually ran the simulation with 1 million dart throws. And the reason is that since I'm doing this on a computer, I can simulate a lot of dart throws very quickly and get a more precise answer. So on the right here is my actual code for those of you who are more technically inclined. And on the top left here, we have the results. So like I said, the total number of darts thrown is 1 million. The number of darts that landed inside of the circular target is 785,930. And when we divide those numbers, we get the ratio of the area of the circle to the area of the square. And so we get that pi over 4, which is the ratio of the areas, is equal to 0.785930. And if we multiply that by 4, we get the calculated value of pi to be 3.14372. The fourth way to calculate pi is to use the volume formula of a cylinder. So the volume of a cylinder is pi times r squared times h, where r is the radius of the cylinder and h is the height of the cylinder. So what we can do is we can take a fixed volume of water, pour it into a cylinder, we can measure the radius of the cylinder and the height of the water, and use that to calculate pi. All right, so for my cylinder, I have this water bottle here, and luckily my water bottle has these volume markings on it, so I filled mine up to just about 500 milliliters. If you don't have a bottle with volume markings on it, you can just use a measuring cup, but you do want to have a cylindrical container, and preferably something that's see-through as well, so you can actually measure the height of your water column. So now I'm going to use my ruler and I'm going to measure the radius and the height of this water cylinder, and we'll use that to calculate pi. So I've just finished up measuring the radius and height of my cylinder. So it's 3.4 centimeters is the radius of the bottle, and 13.7 centimeters is the height of the water inside the bottle. And so now we know that the volume inside the bottle is 500 milliliters, and luckily for us, 1 milliliter equals 1 centimeter cubed. So that's 500 centimeters cubed of water, and so we can go ahead and do some calculations to find out the value of pi. So I've just finished up with the calculations, and so as you can see here, what we can do is use the formula for the volume of a cylinder. So the volume is equal to pi times r squared times h, and we know r and h, and we also know that the volume is 500 milliliters or 500 centimeters cubed, and so we can substitute all of that in and rearrange it to get this nice expression for pi. And when I plug that into my calculator, I get that pi equals 3.16. The fifth way of calculating pi at home, and my personal favorite, is to use a simple pendulum. Now, the physics behind this is a little bit more complicated, but the key fact that you need to know is that the period of a pendulum, or the time it takes for it to swing back and forth one time, is equal to 2 pi times the square root of the length of the pendulum divided by the gravitational acceleration. Now, the gravitational acceleration on Earth is 9.81 meters per second squared. That's a known quantity. And we can measure the length of the pendulum along with the period of the pendulum. And so putting all of that together, we can calculate pi. Okay, so for this last method of calculating pi, I've set up a little pendulum over here using the water bottle from before and using a eraser attached to a piece of string. And you can really use anything at the end of your pendulum as long as it's considerably more heavy than the string itself. So what we're going to do is I'm going to let the pendulum go and measure how long it takes for it to complete 10 cycles using this stopwatch here. And I'm going to do that for 5 trials. We'll average out the values and divide by 10 to get the period of the pendulum. So how long it would take on average for it to go back and forth one time. One thing to note before I start is that if you do want to try this at home, make sure that when you let the pendulum go, it's at a relatively small angle, because the formula 2 pi square root L over G only works for small angles. So unfortunately my camera cut out for a second there, but I did finish the 5 trials, and after averaging it out, we get that the period of the pendulum is 1.561 seconds. And so now I'm going to measure the length of the pendulum, and remember, you only want to measure the actual length from sort of the pivot point to where it's attached to the mass, because that's the actual length of the pendulum, and then we can get to plugging that into the pendulum formula. Alright, so I finished measuring it, and because my ruler is short, I've cut it up into 15 centimeter segments in order to measure the length of the pendulum. And after adding up all of these little segments, I get that the length of my pendulum is 56.5 centimeters, or 0.565 meters. And a note for you, everyone who's doing this at home, make sure you convert your length to meters, no matter how you measure it, because when we plug it into the formula, it has to be in meters to get the right value. So now we're going to use the period and the length that we measured to actually calculate the value of pi. And the formula for that, like I said before, is t equals 2 pi times the square root of L over g. And g in this case is the gravitational acceleration on Earth, which is a known value, and we'll use 9.81 meters per second squared. So after a little bit of rearranging of the original formula, we get that pi equals t over 2 times the square root of g divided by L. And so when we substitute in all the values that we know, so t is 1.561 seconds, the length is 0.565 meters, and g is 9.81 meters per second squared. We put that into the formula. I've used my calculator here, and I've gotten that pi equals 3.25. Now, that's definitely a little bit off from the normal value of pi, but given that we determined this experimentally, I'd say it's still close enough. Well, there you have it. 5 ways to calculate pi right at home. If you enjoyed this video, make sure to leave a like and share this video with your family and friend. Also, if you got to try out any of these methods at home, be sure to leave your results in the comments below. I'd love to see how precise some of you can get with your calculations of pi. Anyways, that's all I have for today, so goodbye and happy Pi Day.